for joining us. My name is Jordan. I'm a marketing coordinator here at SDK. And welcome to Dan Rigg. So he is part of our innovation team. He was one of the key people who put together our Fabric Manager accelerator. So he is just the guy to tell you all about it.
Yep. And I'm Daniel Rigg. I'm a senior data architect with SDK. Was architected the Fabric Manager, and I'm happy to show it off today. Share this screen, and we'll get into Fabric Manager. So today we're going to talk about Fabric Manager. I'm going to start off by introducing a bit of Fabric components, kind of lay the groundwork of where we were operating from when we designed this. Then I'll give an overview of Fabric Manager, and I'll do a little demo. So we won't actually show it running, because if anybody here knows ETL, you'll know sometimes it takes a little bit of time to run an ETL. So I'll save you guys some time rather than just watching the stuff spin around. Feel free to ask questions. I believe we have, is it an hour or 45 minutes we have?
We have an hour.
We have an hour. We have an hour. I shouldn't take an hour, so feel free to stop me and ask any questions along the way. So I'll get to talking a bit about some Fabric components. I don't know where the level of technical savviness of this audience is, so I'm gonna go a little bit high level, and then we'll get a little bit deeper. So Fabric itself has the vision that it wants to supply a software as a service where we have all of our data needs kind of under one umbrella. In the past, we've dealt with things like ADF and a Synapse notebook and Power BI and the data lake, all being their own components within the Microsoft ecosystem. And the interoperability between those things was a bit of a struggle. Like, it wasn't impossible by any means, and it all worked pretty well. But the vision behind Fabric was to get everything under one umbrella, so you could do everything from ingestion to reporting all under the same roof. So you can see in this slide, you've got the factory part of it. We've got the Spark part of it, storage, as well as reporting is all under the same place. And the idea is that everything is under a single capacity, or you can have multiple capacities, but you have the ability to separate your compute and storage, so that you can apply, say, less capacity towards your storage and more towards your compute, and that way you separate those concerns. So if your ETL is running slow, it doesn't bring down your reporting, and it's all scalable and shared in one ecosystem. So when we were set out to build, what we wanted to do is we wanted to build a full-scale ETL, or extract transform load, of getting our data from source into our system, our reporting system, whether that be a dimensional model or an application, all within the Fabric ecosystem. So what we have to do is we have to think about how we're going to store the data and how we're going to transform the data, because obviously that's the big parts of ETL. In Fabric, there are three big ways to store data. And they're all a house. So there's a lake house, a warehouse, and event house. The lake house is very akin to your traditional data lake that you're used to within Azure. They're used for structured, unstructured, semi-structured, basically anything that you can load into the lake you can put into here. There could be anything from a structured table to a video or picture. These are interacted with via Spark, and they do have so when you have two portions to a lakehouse. You have your structured portion, which are your tables, and then you have your unstructured, which is the files. The tables, you can actually apply row level security and column level security to as well. The important part about all three of these is they are backed by Delta. So Delta is an open source file format that allows you to do time travel on your data, and do ACID transactions on it as if it were a database, but they are actually files. And so this really unlocks the usability of a data lake. All three of these use the Delta behind the scenes, but they interact with it in a different way. So Lakehouse I talked about. Data warehouse is very SQL-like. So it's all structured data. You interact with it with SQL. You can apply dynamic data masking, row and object level security. You can do things like DDL and DML. So your traditional SQL admins will be very comfortable with the data warehouse. And there are advantages and disadvantages and use cases for all three of these houses. And then we'll discuss how I used all three in Fabric Manager. And finally, the event house. So the event house is meant for structured, unstructured, semi-structured data. It's really meant for uh, real-time, like time series and geospatial events. So it's you're ingesting streaming events. Where this is really good is for things like logs and telemetry, anything geospatial. And you can apply row-level security on it. It's a little bit less, you can't do columnar and all that, but you interact with it with something called KQL, so Custom Query Language. Uh, and all three of these, because they're Delta backed, you can, again, you can do ACID transactions on it, but as well, you can build semantic models on all three of these, allowing you to do reporting on that. Any questions so far? Nope. All right.
I actually do
Oh,
think Nishan had he put
sure.
some questions in the chat. So he said,
Sure.
we have noted that Microsoft Fabric is being changed and updated frequently by Microsoft. So
Mhm.
how resilient and versatile is the Microsoft Fabric Manager? Do we keep it current? Would it
Uh,
be SAS type code push, or do we need to deploy updated from SDK into their system?
Right. So we do have so Fabric itself with the interoperability, uh, we have done some things in Fabric Manager that you might consider to be workarounds with the expectation that the functionality would come in. So an example of that would be currently a connection to a source outside of Fabric can't be dynamic. I believe they have pushed an update to that in the Fabric during the Fabric conference a couple weeks ago. So something like that where we would come in and we would have to come in and update that. But as far as changes that break Fabric Manager, everything we've done is object oriented and versioned from like a code base, and Spark itself is not going to change. So the big thing about what Fabric Manager does, and I'll get more into that later, is it makes your enterprise ETL scalable because we have built a way to reuse that code and interact with all the parts within Fabric along that way. So yes, there is going to be some things that Fabric will release that will warrant maybe some upgrades to make Fabric Manager better. But from what I've seen so far, nothing they've released has broken Fabric Manager. So from a resilience point of view, what we have built will still work in that way. I hope that answers the
Okay.
question. Hopefully I answer the question a little bit more when I get more into what Fabric Manager is. So this is not a Fabric thing, the medallion architecture. This is a data lake architecture. It's a very common cloud architecture that people use. We've implemented this with Fabric Manager, where you do three hops within your lake. You have a bronze, a silver, and a gold layer. These aren't things you buy or things you install. These are just a concept when we're dealing with a cloud architecture. So bronze being a layer within your lake or a folder within your lake where you're going to store your bronze ingested data. So this is data that I've grabbed from source and I've landed within the data lake. You don't want to do any transformations at this stage. You don't want to fail your ETL at this stage. You want the data in the lake before things like schema evolution in your systems or whatever are going to fail the system. Um, Bronze is this landing zone. So, and we can do either full or incremental loads. So a full load would be every time you load it, you're going to query your entire data set. Incremental would be we have a watermark and you would query just what we haven't ingested in the past. Both of them are supported within Fabric Manager and should be supported in most modern ETL systems. Silver is where you want to have your curated source of truth. You don't want to do business transformations from bronze to silver, but what you do want to do is you want to apply your schema. You want to cleanse, deduplicate. You want to tracking history is a good idea. So what I mean by that is doing type two or having every version of a record for a table. Generally, your silver table is going to match your source table. And silver then becomes your source of truth within the lake. And this is normally bronze, you don't want anybody to have access to except for the people doing development, the ETL itself, or if you need compliance or auditing. Silver can then now be accessible by data scientists or power users who just want the source data but in the cloud, and they can do things within it within Fabric. Gold becomes your application layer. So I've created a dimensional model. I've created maybe a relational database for a downstream application. I've created some sort of application ready model. And so gold is where I'm from. Silver to gold is where I do all those big data transformations to get that ready for my reports downstream. So that's storage. Again, stop me at any time if you have questions. I'll let Jordan field anything in the chat and stop me if there are anything. But the next stage is transformation. So I mentioned those 3 hops. So how are we going to be doing those hops? So data transformation in Fabric happens again in 3 ways, or the 3 major ways. There's pipelines, there's pipelines, there's data flows, and there's notebooks. And so a pipeline is what we for Fabric managers, a pipeline is more of our base unit of work. So a pipeline does a thing. So it ingests a table from source to bronze. It'll send it to something from bronze to silver, but mostly because of its orchestration capability. Because you can do, and this is going to be a low code, no code solution. It's honestly almost feature to feature as Azure Data Factory, and it will become feature to feature with Azure Data Factory in the future. So if you're familiar with that, you'd be familiar with this. You have a low amount of connectors, but still a pretty good amount. For copying data from a outside system into the lake, the copy data task is still one of your most performant ways to do that because of the way that the compute scales. And so we like to use this for ingesting data from source to bronze. But you'll notice that you can also, the other 2 transformation types of a notebook and a data flow, you can run those within a pipeline. And so that's why we use the pipeline as our unit of work that we're orchestrating. And if we need to do those high-end transformations in a notebook, we can just replace this copy data task with the notebook. For notebooks, now these are running multiple languages in very high code. So you can do everything is going to be Spark behind the scenes, but you can do it in Python, Scala, SQL, or R, and you can even mix and match within your particular notebook. So you can have one cell in Python, one cell in R if need be. This is really big for doing your high complex transformations. Spark does parallel compute. It distributes your processes, and then it allows you to do really big data transformation very quickly once it's in the cloud. So that's why we're recommending doing the copy data to get it into the cloud. Once it's in the cloud, your notebooks are your highest performance to do those big transformations for a lot of data. And finally, there is the data flow. Now, the data flow is a really powerful tool. This is very much like data flow Gen 1 in Power BI, but data flow Gen 2 has a Spark backend, so it's a little bit more performant. It's low code, no code, but it uses Power Query, so you do have a high code option, has a lot more connectors and a lot more transformations than, say, a pipeline. The problem I find with this is it is a little finicky and slow to set up, and it's hard to scale it. What the use case to data flows I've found is for data wrangling. So if I had mentioned in Silver, you can give your power users access to that Silver. If they want to go in and just do their own like ad hoc transformations to explore the data and profile the data, and they don't have that Spark background, data flows is your next best thing. We did not implement data flows within the Fabric Manager because Fabric Manager is meant to be a scalable ETL. The data wrangling portion of it is more of a user thing, and so that didn't make it into our accelerator. But it's still interesting to note that this is available to you within Fabric. So those are kind of like the high scale things within Fabric that we talked about. Again, please ask questions if you have any. But next, I'm going to get into what Fabric Manager is. So what are the benefits of an accelerator? So what is an accelerator? An accelerator is a pre-built framework with templates that ultimately what we want to do is we want to be able to come in and deliver faster, which is cost savings that we're passing on to the client. So we've done a lot of work internally to develop this methodology. It allows us to ensure consistency of our code, ensure best practices, and that allows us to deliver a scalable enterprise ETL solution very quickly. And so that's like why we would use an accelerator, what we did, and the why Fabric Manager, I guess, as well. So it's data driven. So I mentioned scalable quite a bit, and the reason for that is it's all data driven. So it's built off of templates that are controlled by configurations. And so to change, remove, add, or disable pipelines, that is as simple, most of the time, as simple as just adding or changing records in a database. So I need to add 100 tables. I don't need to create 100 pipelines. I just need to insert 100 records into a configuration database. A big thing with our Fabric Manager that you don't get out of a lot of like rudimentary ETL stuff is the ability to monitor system health and resume jobs from the point of failure. So what does that mean? Let's say I have a 100-step process in my ETL and it fails on step 99. On a less robust ETL solution where you're just orchestrating pipelines on a trigger, you'd have to start over again from square one, and it'll you fix your bug and you fix your data and you run from 0 again all the way to 100. The way we've developed it is we have things like resuming from failure, which means that I can just restart step 99 and it just does step 99 and 100. So we took a lot of that into consideration to make this more supportable and usable by the end user as well. So the architecture of Fabric Manager, I won't get too deep into this because I'm going to show a bit of that, but we tried to implement the entire Fabric Manager technology stack, and what was very important to us was keeping everything within Fabric, because the idea is that if a company wants to come in and build an ETL, it's a lot easier for them to figure out that, okay, I need a Fabric capacity, and now I'm good. Right, because if we went outside of Fabric, then we have to consider provisioning all those other things. Now, obviously, there's still permissioning and Key Vault and stuff in Azure, but generally, if you have Fabric, you've got Azure anyway. But we're not going outside of Fabric to kind of keep all of that in a nice little bundle. We ended up using a warehouse to do our configurations, and the reason for that was because it's very SQL-like, so it's a lot easier to support because most of the people who are supporting systems like this are very used to SQL, and it supports scalability and also that those row level and column level security is really good. Airflow is a Python-based orchestration tool that is. It is an open source technology, but there are implementations of it, and there is an implementation of it within Fabric. And Airflow is very powerful as far as being able to do orchestration. And it does a lot of things for us from functionality as far as UI and reporting, logging, as well as that restartability I mentioned. And it handles your batches for you. So you don't have to like create a batch ID system. It does all of that for you under the hood, which is really powerful. Fabric Data Factory, or the pipelines, is our units of work. So Airflow is going to be orchestrating each one of our pipelines. And then the Storage we had in a lake house. I don't have that on this slide, but all of our storage is in a lake house. Our logging is done with an event house because all of our logs are going to be streamed as time series, and that is what event house is based off of. And everything is under Power BI because Fabric is housed within the Power BI engine. So obviously our reporting is going to be in Power BI as well. It's a diagram of the architecture. I don't think it makes sense to go too far into this, but there's that multi-hub system. We're using pipelines and then notebooks to transform. We're reporting off of Gold with Power BI and then orchestrate it all behind the scenes with that Airflow and environment pipeline warehouse event house. And I'll get more into each one of those things during the demo portion of this, which should be coming up pretty quick. But so another thing I had mentioned about with scalability is we have a central orchestration, a central configuration, but you have the ability to run multiple jobs. So just based off of configuration, you can have one team have a job with all of their units of work, another team have a job with all of their units of work, another team have a job with all their units of work. Those are all going to be under the same central orchestration and configuration database. They will not interact with each other unless you want them to, and they are able to trigger their jobs independently. So that's the tenet that we wanted to do with this particular process. And finally, so I didn't touch on this, but Fabric uses workspaces as logical containers. You can have workspaces in the same capacity or in different capacities. Our architecture, we wanted to implement a three-tiered workspace approach. And so what we did is we had a storage workspace. So this holds our configurations and our silver and bronze data. This is actually out of date because gold is in our reporting workspace, but and this allows you to separate that compute from the storage, so that if you wanted to, if there was a problem, you could have this on its own lower capacity. It won't interrupt the reporting, but your ETL could be on a higher capacity because that's where all your compute is. And so you could have the lower capacity always on, and the compute capacity could turn on and off. There's a little bit of flexibility there. So we wanted to separate our compute from our storage. We have reporting in its own workspace as well. Reporting generally is going to be on your gold layer, and that's why we put the gold data within the reporting layer. This slide needs to be updated, but that is our three-tiered approach for workspace. And we come in with templates. So I've mentioned this a few times. So this is all data-driven and configuration-driven. It's based off of templates that we've developed. So we have a bronze to silver. We have a notebook template, a template that all it does is runs a notebook. Everything within that is parameterized. So I have one pipeline that will run every single one of our notebooks because all you have to do is instantiate a version of that pipeline with different parameters based off of the configuration. The one we're seeing here is our copy data one. So all of our templates are going to look up parameters. So that's what allows them to be data driven. So I can reuse this pipeline without having to make a whole bunch of them. And all of them are going to send logs. So the start is the parameters, the end is the logs. The middle is where it does its work. So in this case, it's a copy data task. So the copy data task being, I'm going to query a SQL database. I'm going to ingest it into bronze, and everything within copy data is parameter based as well. So it builds out that SQL query to the table, to the source, all done through parameters. And I'll get more into the pipelines in the demo as well. Monitoring, we have a operational report to allow us to view system health. So this is all based off of that KQL event house with all of our logs. So all of our logs get streamed into this database, and we can report off of that. So the built-in report that we built with our accelerator is for monitoring system health. So it isn't meant to be for a run-to-run investigation at this point. It's more for, is my run taking longer? What's my failure rate? What kind of errors am I seeing the most? So that allows us to address those issues from like more of a high level approach. And so that's all built in within our accelerator as well. And then finally, before I get to the demo, is orchestration. I've mentioned Airflow quite a bit. So Airflow is a Python-based tool, and you build what's called a DAG. DAG is a directed acyclic graph, which is essentially just a workflow. So it has a start and an end, and it doesn't loop on itself over and over again. But the big thing with Airflow is because it's Python-based, and because it's distributed compute as well, it allows us to build some really powerful workflows. So you can do pretty much anything from like how you want to organize and orchestrate your ETL. And it also has a lot of built-in web-based monitoring, built-in retries, built-in batch control. You can have lots of plugins. So it's a very powerful tool for orchestration. And this is an example of those monitoring tools you get. So out of the box, you get these like graph views and these really nice views and logging that I don't have to set up. Like it's all built in with your Airflow. So now I'm going to actually go in and show stuff. But before I do that, are there any questions?
Yeah, we have a couple of questions in the chat.
Sure.
So the first one is, does Microsoft Fabric Manager allow for failed jobs to not rerun or to restrict how many times to rerun?
Yeah, so there are retries that you can configure for each task and at the DAG level. So that's all built in with like Airflow has that built in as code, and then we've configured that. There's as far as like those parameters I said, those are job level parameters that you can change and configure. We can control those retries. And when I say restart from failure too, you can do that like we do that manually because chances are it's failed. So most of the time, it's gonna an error, a failure is usually because of either a bug in your code or an issue with the data. So you would fix that, and then you could rerun from that point in failure. But built in, we do have automatic retries because there is the odd time where it fails because like your Spark session doesn't create or like just like little blips in networking. And so we have the retries built in, and that's all configurable. So you can retry the entire DAG, or you can retry each individual task.
Sorry, Daniel, I'm going to speak up
Yep.
here.
Yep.
The question was from me. So essentially, what we are having here is we have a data refresh every minute as our target state. And what happens is sometimes because of these little glitches you mentioned, the previous instance of the job will continue to run while the next instance creates and instantiates and executes. And that creates data duplicate issues for us.
Right.
So that's why what we wanted to do is understand, because we couldn't tell in Fabric right now. So we were hoping or wanted to know if this manager can allow us to set and say, do not rerun any jobs, because our code accounts for look back and getting the failed or the missed data set.
Right. So that is possible. I don't believe that's built in as something we've set up, but I'm pretty sure I know how I would do it in Fabric Manager. It is possible to do that. Also, what we have done is we set up everything to be idempotent. So if what that means is that if I apply data, the same data twice, it shouldn't create duplicates. You'd get the same answer. So idempotency is f of x equals f of x. So essentially, with your issue, I'd have to see your specific issue, but we shouldn't get duplicates in silver, even if that particular thing happens, because of the way we've done our idempotency.
Sorry, I just want to be sorry for interrupting. I just want to be clear. So what you're describing, Daniel, is part of the Fabric Manager, not part of the. Okay, good.
All right. So that's our code that we have built. So Fabric itself, I don't think I can't like there are Fabric itself like I would have to again see your situation, but our code is resilient enough that it shouldn't create duplicates in silver if that happened. And that's based off of we built a library that I'll show when we get to the notebooks that does all that merging and stuff. But Hopefully that answers the question. Yeah, like Fabric itself, like the airflow part of it, you could, like, you can start another run, but there are things that you can do to create it so that it checks to see if there's a currently running one. But we haven't implemented that in Fabric Manager. But you can code that within Airflow. I know you can. Hopefully that answers the question. Sorry.
Nishan, do you feel like both your questions got answered there, or?
Well, the first one did, but I think Michelle is on my team as well. So I don't know if I think Daniel, you may have answered the questions as well, based on the power or the configurability or the options that controls that you have with Fabric Manager. The other question I had is you mentioned using so you mentioned using Warehouse. We went with lake houses because we had the need to import data from unstructured files like CSVs and spreadsheets. Did you account for that as part of your SDK?
So we use Lakehouse for bronze and silver. Okay. We use the warehouse for our configurations, because the configurations for the ETL, it is essentially a database, right? So we're reading a database for the configurations and we're managing it like it's a database, even though it's files. So that's why we use the warehouse, and it does allow you to have that. Those like security, like the data masking and all that stuff that is important for the configurations when you're talking about multiple teams. But that's why we did this. The actual storage, we did Lakehouse, especially because of what you said. Like, so bronze, if you're bringing in JSON or CSV, obviously we can't bring that. Well, you can't, like, there's a hop, but like, we want to land that as JSON or CSV. And so we would land that in bronze for the unstructured.
Understood. And then, sorry, I just want to be clear. So silver and bronze, you did Lakehouse, and then your gold is warehouse.
We did Lakehouse, but it's interchangeable in our situation. So we did Lakehouse. I believe the big reason for that was just from a Spark perspective. Like, we wanted to load it with Spark and not have an extra step, because you can't, or at the time we built it, you could not insert into a warehouse with Spark, and we were building it with notebooks. And so we didn't want to have to run a store procedure to do it. But you could interchangeably do that. And there are benefits, again, from a security point of view to do a warehouse. You can do that row and column level security in a Lakehouse as well on the SQL Analytics endpoint, but you don't have the ability to do dynamic data masking. So there's a little bit more security power behind a warehouse. We did a Lakehouse. It was the easiest way to do it from our thing, but you could do a warehouse.
Okay, I think that's good. I don't want to monopolize your time, but maybe Jordan, you can email me after, because we are a public organization, so I can't say too much, but there is an RFP out around Microsoft Fabric. Okay.
Yes, I knew that. I knew about that one, actually.
Okay, sounds good.
All right. So this is Fabric. For people who haven't seen it, it's the app.ihavepowerbi.com, because I've been grandfathered in. I don't know if everybody has, but everybody has that. But app.fabric.com is the way to go. It's a portal that looks a lot like what Power BI did before. And I had mentioned workspaces before, so we have the ability we have a whole bunch of workspaces within our capacity, within our capacities, because this is all of them. And I have the ability to filter. So I'm going to filter down to Fabric Manager. And so we have our 3-tier workspaces. So our ETL with all of our compute. Our ingestion workspace is where we have our configurations and our bronze and silver data, and our event house for logging. And then business data is where I mentioned that gold Lakehouse, as well as the reporting. So for the ingestion, like I mentioned, so we have that warehouse. The warehouse being where we have the configurations. Lakehouse mentioned as the bronze and silver, and the event house is where we do our KQL. I'll get to that one near the end when I talk about the reporting. But the warehouse itself, you'll see it looks a lot like SSMS, and in fact, you can query any of these from any of the houses from SSMS as well, and you can query them all here within the within the UI, and so it looks, and it is SQL. So and when we're querying it, so these are all of our configurations. So we have jobs. So the job level is an entire run. So if I have an ETL to load a particular dimensional model, that's going to be a single job. If some other department has another dimensional model and they have their own ETL, that's going to be a different job. So internally for our demo, we have the two jobs. So there's the master one that does all the compute, and then we run our dim date on a separate job, just to show that we have two jobs. Each unit of work within the job is going to build out a hierarchy of pipelines. So each pipeline will correspond to either a node or either a node, which is nodes are run in series, and then a node would be like my bronze to silver node. Which in this case here, this is source to bronze, copy adventure work tables from source to bronze. Everything under that node, so is going to be a pipeline. So this corresponds to running a particular Fabric pipeline. And so that pipeline name is in the pipeline column. I'm going to run this pipeline with this description. All of these run in parallel. So nodes run in series. Every node is going to run everything under the node in parallel. Each pipeline and job gets their own parameters. So I'd mentioned that we can parameterize anything. I have this same pipeline being run for all 25 tables, I think it is. So each one of these pipelines is going to have its own pipeline parameters saying what the table is, what my watermark column is for doing incremental, what my select columns might be, because if I wanted to exclude some columns, et cetera, and that's all, and that's controlled by your parameter table. And then the watermark table, this is how we handle incrementals. And so what we're going to do is we're going to run our query based off of the watermark column, which is parameterized, between the next start and end date. And this gets updated every run so that we can run incremental. Within here as well, I can disable or enable the pipeline, as well as this is all automatically generated as well when you create a pipeline record. So I don't have to know to create a pipeline record and then a watermark record. And so this is how we handle our configurations. When we're loading our configurations, we have a lot of data quality checks with a store procedure, as well as we use store procedures to disable and enable pipelines. So that's how we use the warehouse. For the lakehouse, there are two types of objects within a lakehouse. There's files, which is where you put your unstructured data. This is where we land all of our bronze data. So everything within here is a file. So if it's querying from a SQL database, it ends up as Parquet. But if we're going to transfer, say, a SharePoint list as a CSV, or if we're going to transfer a JSON from an API, those are going to come into this table as a CSV or a JSON or a Parquet. This can be anything. And we handle incrementals by breaking each one of these up into the date of load. So each one of these gets a timestamp. So if you're doing full load, each one of these is going to have a full load of the data. If you're doing incremental, this is going to have the incremental that was loaded at that time, incremental that was loaded at that time, et cetera, et cetera. The table object is structured. So table is delta backed behind the hood. This is where you can do that row and column level security. You've applied a schema, you do that curated. This is our silver layer. And we have done, what's a good example? We have done type 2 on everything, which means that we've tracked history on each record. So this particular record, if something change, I mean, country's not going to change, but if Bulgaria changes to a different country name, then we would see that it was Bulgaria, and then then if it changed, we would get this would change to current false, and then we would get the new version of the record. And so we've done that in silver with every table is type 2. Yes, everything here is stored within a lakehouse. So that's our storage. This is again, we can separate that from the compute. For our ETL workspace. This is where we house all of our pipelines, notebooks, our Airflow orchestration, as well as the environment. So you can see we only have 4 pipelines to do all of the tables from bronze to from source to gold. And we do have a number of notebooks because notebooks are going to be a little bit more sparse, but we have one particular pipeline that runs a notebook. So actually, before I get too far in, I should start this compute, which I should have done before. And then when we get to it, hopefully it's on. So I've showed this a couple times. This is our pipeline template. All of our pipelines get the same parameters from Airflow. Airflow handles getting the individual job and handles the run ID. So this is like a batch ID, so DAG run ID. It handles all of that part of it, and it sends down the job ID and which pipeline is running, which pipeline ID is running. Then we use those values to look up those configuration tables I showed you. So we're going to look up the pipeline parameters, the job parameters, and the watermark lookup in order to do this work at scale. We're going to do our copy data in the middle, and then we're going to log at the end. Very similarly, I have a run notebook. It looks almost identical. It has those same parameters here. It's doing the same lookup here. It's going to run the notebook. Fabric, I don't know if it's changed now, but you could not run a notebook based off of a name dynamically. You had to use its ID. So we used APIs to look up its ID based off of its name. I think they've changed that since then, but that would be an example. I think you had asked earlier about, but this shouldn't ever break, but we might come in later and update it so it's a little bit cleaner. And then logging at the end. So we come in with these templates. I guess the downfall sort of is like this template that we've pre-built is for an Azure SQL database to bronze. If what we don't have currently internally is other templates like maybe an Oracle or SAP or something like that, those are pretty easy for us to build. We would just have to build this out and make sure whatever thing we have in the middle, but that accelerates us to be able to build those templates very easily. And then we'd only have to build that template once, and then we use configurations to execute that template over and over again. Sorry, I have to move this share. And then we have notebooks. So I talked about how we run notebooks. So I kind of talked about this as well too. We have a Python application that we've developed that does our merging. So it handles everything from bronze to silver and silver to gold, and we've packaged that into a wheel file. So a wheel file is like a zip file with Python code in it, and then we've put that code onto our library. Why did we do that? Well, it's a lot easier to run unit testing in that manner. It's a lot easier to version our code and deploy different versions of the code. And then also, if somebody's familiar with notebook execution of code, when you have to string notebooks together, it becomes a lot harder to debug. So what I mean by that is I have common code I want to be run by multiple notebooks. I'd have to run a notebook from a different notebook, and it kind of obfuscates that level of error handling. And so I really don't like that style of development. So the notebook itself is kind of just a wrapper to run our centralized code. And so what that looks like is just we do an import. So we're going to import here it is. So we have our library we developed is called Fabric Manager Core. We're going to import that particular those libraries. So in this particular notebook, we're doing our dim and fact loader. And then all this notebook is going to do is grab the parameters from the pipeline and then execute the loader based off those parameters. With Fabric Manager, if a client is going to hire us to implement Fabric Manager, they get entire access to that code. It is not It is not like a obfuscated code. It's not like when you buy Windows or whatever. I don't have the kernel or whatever it is. That code is just a zip file with the Python code. It's just we like this method of executing the Python code better. It's not something proprietary. Well, I mean, it is proprietary methods, but like it's something you get access to. So this is the environment. So I should have mentioned that here. You can run your notebooks on a Spark environment. You run your notebooks on a Spark environment. And so we've set up an environment object as our workspace default. And so what that allows us to do is install that wheel file onto that environment so that we can access it from all of our notebooks. And you can even install, we use LogGuru for logging, and we do some Azure Event Hub stuff. So you can install public libraries as well on that environment. And you can change like Spark properties and stuff like that. And then the next thing I'll talk about is Airflow, but are there any questions behind that? Because this is still currently running. And I'm talking pretty fast and getting a little technical, but.
We have lots of questions, Daniel, but
right.
I think we may need to wait till maybe a private consult.
Yeah, we can connect afterwards, Nishan. I'll email you guys.
So this is where you put the Airflow code. I should have started this earlier because it takes a little bit. We're only on a starter pool right now, so it stops after 20 minutes of inactivity. And I should have started it earlier so I could show it off. I'll get to it when it starts. I'll go through the other stuff and come back. But this is where you put your DAGs. So again, it's just Python. I'm not going to go too deep into the actual code, but you build out tasks that Airflow runs on a DAG, and you can do it all through data-driven code, which we did, which I will show when I actually show the monitoring, just as it shows off a little bit better. And then you can even put in plugins, which are libraries as well that your DAG uses. So in our case, we are executing the Fabric pipelines using an API. So we created an API library to be able to execute those pipelines. But I'll show off the Airflow when that starts. In the meantime, I will get to the gold layer. So again, we have our gold is in a lakehouse. That I'll show here. So this is where we put our DIMs and facts, all within the tables object, because again, our gold layer is structured data. And I had mentioned before, you could put this in a warehouse very easily. And our DIMs and facts are here in the lakehouse, and then we've built semantic models on top of that to do our reporting. So I'm running a little bit out of time, so I won't go too far into that because it's just showing kind of the same thing again. And then the final thing before I get back to Airflow is our event house. So this is an event house. It's a KQL database. So we get time series record. Each one of these is our logs. So our entire system, our pipelines, our Airflow, and our notebooks all send logs to this event house. And they all come in with different error levels, different levels of information, messages, metrics, etc. But the big thing behind this is, again, I've mentioned this, is you can build a semantic model on a lakehouse, a warehouse, or an event house. So we built our semantic model on top of this data, and that is what our performance report is. So in this case, we can see how long a particular DAG is taking. You can filter by period. And you can see how many rows are written and read per second. So we're kind of assess the system health. When we do assess performance analysis, we can do an individual job analysis. So I have it to all. This might take a little bit. So if a particular job, I want maybe Fabric Master, it shows this. I can see the time of day that it's being run, how many times a day it's run. These are each individual pipeline. It will tell me whether or not it's above or below, or I think it's just above the median job duration. So this will highlight spikes. So this particular node is taking longer than it normally does. I don't have any examples of that right now, but we could see how many pipeline failures were on each particular pipeline. These are the details, but no, it's not the one. Yeah, you can drill into the details with these ones. And then we also have an error analysis one. So we can see what errors are we experiencing, like where they're failing, how many of this type of error are we getting, and this allows you to do more investigation on system health. On a general day-to-day, your support person is probably not going to look here for one particular error, although we do have, this is where the error is. It is easier to go to the source to find out what the error is, so usually airflow. This is more about assessing overall health of the system and things that could be done to improve it. And so I feel like this is something very powerful that we give as well out of the box with our solution. So hopefully this has started now. Not quite. I can show what I have here, but I just can't click around in it. So this is Airflow. This was loaded yesterday, but so Airflow gives us this UI. So you build that DAG with code, but it gives us this UI to monitor it. And so this part here is really powerful. So each one of these columns is a run of a particular job. So I have a particular one job running. Yeah, I get you. I know you're off right now. The top bar shows the duration. You get nice tooltips or whatever. So I see this one took an hour and failed on that node. This one only took 4 minutes. This one took 55 minutes and ran all the way. Each one of these boxes is a particular pipeline. These are tasks that are built out within that DAG. The big units of work is that this is a node. So this is the like copy bronze to silver pipelines. This is source to bronze pipelines. This is bronze to silver pipelines. Within that, we get all these map tasks. So each one of these is a single Fabric pipeline run that are all running in parallel. You can control that degree of parallelism as well. So with a parameter. So right now we have it run in batches of 10, just so we don't have too many pipelines running at once, taking down the capacity. You could, if you have a bigger capacity, you could go higher. If you have a smaller capacity, you could go lower. I haven't stress tested what our capacity can do. We just have it to 10 and it hasn't been an issue yet. I'm sure it could go higher, but that's for each individual one of these. For a particular, I really hope it's on. I should have started it earlier. That's my bad. I'm sorry. So I want to be able to click around in it. It's taking a sweet time. For each one of these tasks, I can see any event logs on a particular task. I can see that graph view. I wonder what it will do. Yeah, that's what I thought. So you can see that graph view that I showed in the presentation. This is a demo one, but you'll see a graph view like this. And you'll be able to restart from failure by selecting the one that failed and clearing the task. And so it gives all of that just like out of the box with the UI. And you can control which, like you can trigger DAGs on a schedule. Schedule is applied through a parameter. You can see your list of tags if I clicked on the DAGs portion here, but again, it won't work until this thing is on. I wonder if it's on now. Oh, it's on. There we go. Perfect. All right. So these are our DAGs. You can disable and enable them right here on the pause on pause. You can see recent runs. So you can see I have, it's actually running because I just turned on the capacity and this one's set to run on a schedule. It notices that it didn't run the last time the schedule was supposed to fire. And so now it's firing it now. So this is the dim date. So we can actually go in and see one running. So we can see that it is here on this this particular task. And I can look at the graph view and select a particular run. So I can see that it ran these successfully. If I hover over it, I can see the duration of each task. So 1 second, 7 seconds, 0 seconds. So this one is the one that's going to be doing the work that's spinning up a Spark cluster on, or a pipeline and a Spark cluster on Fabric. And for this particular one, like I had mentioned, I can go in and I can look at the logs. Sorry, they changed the UI with so this is the Gantt chart. You can see how long it was queued for, how long it was running for. They changed the UI a little bit in 2.10, which was released last week. So I am just trying to find the logs on the spot right now. So I can see the code. Okay. So I'm looking at the map tasks. This is, we go. So I can look at the logs and I can read these logs to see what failed. So in this particular one, it failed on the notebook. It's not interesting for me to show you here, but I can read these logs and figure out what the error was, and it's all within this UI. I didn't have to do anything to set up this UI or to get the power of this UI. That's all part of Airflow, which is all housed within your Fabric capacity. And that's everything I had to show you today. So unfortunately, we only have 2 minutes more for questions, but obviously you can reach out to Jordan or myself and we can connect otherwise. But if there's any questions that you want to ask in the last 2 minutes, let me know.
I did have a quick one, Daniel. It doesn't look like
Sure.
anyone else is going to ask.
Okay.
The error messages that you just mentioned, we noticed
Yep.
that in Fabric, they're usually generic. I don't know, maybe if that's what you saw as well, but does the Fabric Manager append and give more enriched error, meaningful error messages?
Not at this time.
Okay.
We would just get this error message from, like, as a support person, what I would probably do is I would come here, I would look at this particular error. It's telling me a notebook failed. And what I would likely do is go to that pipeline. I think that actually gives you a link to the pipeline. It does here. So I would go to that particular pipeline and I would investigate further. So the actual like monitor tab within Fabric allows me to investigate that a little better. So sorry, I don't know why it's taking so long. Yeah, so Fabric itself has a monitor tab. Which you can see all of your previous runs, and you can see your Spark sessions that are created as well as your pipeline runs. We were really looking at using the monitor tab within Fabric Manager for our logging, but there aren't very good APIs to consume it. But it itself is a very good tool. If it ever loads, it's demo gods. I didn't do my sacrifice. All right, so now I clicked that link from Airflow and it brought me directly to the monitor of this particular pipeline. I can go here and I can see the more detailed error message. It's saying the right operations. This is a kind of generic error. Yeah, so it says a concurrent update. So I probably had 2 runs happening at the same time on the same table, which is usually a no-no, but as well I can further filter down to the particular Spark monitoring as well. So I can go to the execution of that notebook as well within the monitor tab. And I just wish this loaded a little better, but I can go to that particular error and see which line of code it errored on, because all I got was the last error. So if I go to item snapshots, I will see the run that I got. So this is the notebook that ran nb_dim_date. And then this will be it's telling me everything here that ran. It's telling me which parameters it ran with, and then I can see which particular cell it failed on, which is this one right here. So it failed on the dim date. And so again, I'm pretty sure it probably ran this twice at the same time, but I can see now I get a little bit more information, and I can go in and do more investigation. So that's kind of like how you would do this as somebody who's investigating the error. Yeah, unfortunately this time we don't, like we were debating, we were looking into using AI to investigate the errors and give a plan of action, like a rudimentary or a first plan of action. Like we were looking into that. We never got around to that, but we were thinking about that.
Okay, great. If you have time, I know Michelle's our last one standing, but they just had a question. How
Yep.
long does Fabric Manager keep the logs?
For our so our event house forever, unless you purge it. The actual airflow, I don't know the number, but it's a pretty low number. So if I were to go back to one of these, I don't believe I can see the logs from like. Oh, I guess I can. But I don't control the what I'm more getting at. I guess this is still April. What I'm more getting at is I don't control the logs purge from the logger in airflow. I want to say it's less than 2 weeks. They purge, but we capture the important logs within our event house, and they are stored indefinitely unless there's a need to purge them.
Yeah, that's great because from the Fabric monitor tab, the logs not keep more than
Yep.
30 days, and even within 30 days, it's very hard to find the
Yeah.
details. So if
Yeah.
you keep the logs longer here, that's will be very helpful.
Yeah, this here when we stream all the logs. So we've custom, like we don't get every log, but we get every error. We log durations, and we log some info as well as some metrics. So things like how many rows were written, so how many rows were read, et cetera, et cetera. All of those get streamed here, and these are logged indefinitely.
Great, very helpful.
Yeah.
Thank
Awesome.
you
Yeah,
very
Michelle,
much.
I'll reach out to you and Nishan, and we can book a
Sure,
consult
sure.
if you guys
Yeah.
have more questions. But thank you so much for joining, and thank you, Dan, for a great
Yeah,
presentation.
no problem.
Thank you.
Thank you.
Bye.
All right, have
Bye.
a good one.
Have a great day.
You too. Bye.
Bye.